All right. Good morning, Honors Lesson 2. Today we are going to be talking about in 5.4 factoring the greatest common factor, or GCF, as well as what's called the difference of squares. Before we do that, we're going to talk about what's called the zero product property, which zero product property basically says this. If you have two different quantities multiplying to be zero, if A multiplied by B equals zero, then either A has to be zero or B equals zero. In other words, if you had something where, let's just say, you had two numbers, let's just say 5 multiplied by something equals 0, then that something has to be 0. Or if you had something multiplied by 5 equals 0, then that something has to equal 0. Or maybe 0 multiplied by 0 equals 0. In other words, if you're going to multiply and get 0, one of your quantities at least has to be equal to 0. That's been a big idea as we solve quadratics, and we're going to look at it in a little bit more complicated sense in that we're not going to look at it in terms of just numbers, we're going to look at it with expressions. But it works the same way. If you got this expression multiplied by this expression, then in order to get a product of 0, then at least one of them has to be 0. So let's first look at x minus 3. Let's set that equal to 0. And that way it's 0 multiplied by 3x plus 4 equals 0. In which case, to solve, you just add 3 on each side. You get x equals 3. Or maybe that's not equal to 0, but 3x plus 4 is equal to 0. In which case it would have been that x minus 3 multiplied by 0 equals 0. So to solve this one, let's just see. We subtract by 4 on each side, so 3x equals negative 4. And then divide by 3, so x equals negative 4 over 3. All right. For this next one, on number 2, let's take a look at it. So the first quantity, even though it doesn't have parentheses around it, is x. And so we do have to set x equal to 0, and that's going to be one that you've got to remember. It's easy to forget when it's just x, but you do have to set that equal to 0, and notice that it's already been solved. X is equal to 0, and you're done with that one. So then you take the next one, 5x minus 3, set that equal to 0, and solve. So 5x equals 3, and x equals 3 over 5. All right. This last one, once again, I'm trying to show you something different on each one. Technically, this last one has 3 different factors. The first one is 2. And so you set 2 equal to 0, and 2 won't ever equal 0. So you're not going to get a solution there. The next one is 3x minus 8. Let's set that equal to 0. And so for that one, we add by 8 on each side, so 3x equals 8. Divide by 3, so x equals 8 over 3. And then the last one here, I'm going to take negative x plus 7, set that equal to 0. So I'm going to have negative x plus 7 equals 0. And so to solve, I'm going to subtract by 7 on each side. So negative x equals negative 7. And then here to get x as a positive value, I can either multiply by negative 1, divide by negative 1, or I can just switch my signs everywhere and say that x is equal to a positive 7. Okay, so there's zero product property. There's how that works. We're going to be using that quite a bit today as we look to solve. Let's talk about what GCF is, or the greatest common factor. So what the GCF, or greatest common factor, is, I'm just going to spell this out. So GCF stands for greatest common factor. It is the largest quantity that can be divided in an expression. Okay, so let's take a look at it. What you're going to do on something like number 1, and you probably wouldn't use GCF on something like number 1, you'd probably just solve that like normal, but you're going to look at between the 2 and your negative 8, what is the largest number you can divide by? And that number is a 2. And so we're going to do what's called factor that out, meaning we're going to still keep the 2, but in parentheses we're going to write what our expression would look like if we were to divide everywhere by 2. So 2x divided by 2 would be x. Negative 8 divided by 2 would be negative 4. And that's equal to 0. At which point, once you've factored and once you've got it to where it's a product to multiply by x minus 4, then I can go ahead and work it like I did the first three. So I can set 2 equal to 0, which isn't going to happen, and then x minus 4 equal to 0, and so as a solution I get x equals 4. Okay, next one here. Let's take a look at number 2. So GCF between 12x squared and 10. Looks like the largest number I can divide by, once again, is a 2. And so when I divide by 2, oops, let me see if I can figure out what's going on here. Okay, now we got that figured out. 12x squared divided by 2 is 6x squared. And then 10 divided by 2 is 5. We're going to set that equal to 0. And then now, if you notice, once again, you've got a product where you're multiplying 2 by 6x squared plus 5. And let's see, 2 1 equals 0. 6x squared plus 5 equals 0. And at this point, let's save this one for tomorrow. So I guess by tomorrow, I mean Monday. Let's save that one for Monday because we'll look at how to solve by square roots, but we would continue to solve from there. Okay. Last one here. 3x squared plus 9x equals 0. Here, the largest thing we can divide by, largest number we can divide by is 3, but we can also factor out an x because both terms have an x in them. And so let's see, 3x squared divided by 3x, it's just x. 9x divided by 3x is 3 equals 0. Now we can go ahead and set everything equal to 0 because you've got multiplication here between 3x and x plus 3. So you'll set 3x equal to 0. Man, doing it again. Okay, so you've got 3x equal to 0. Divide by 3 on each side. Get x equals 0. Then you've got x plus 3 equals 0. Subtract by 3 on each side. And x equals negative 3. Alright. So, just as a warm-up for our last thing that we're going to look at today, which is going to be difference of squares, let's go ahead and multiply out x plus 6x minus 6. I'm going to give you just a little bit of time to do that. So if you'd like to pause the video and work through that, go ahead, and then I will show you what I got as well. Okay, so when you look at this, and I'm going to distribute, so I'm going to say x multiplied by x is x squared, x multiplied by negative 6 is minus 6x, 6 multiplied by x is 6x, and 6 multiplied by negative 6 is a minus 36. At which point to simplify, negative 6 positive 6 add to be 0, so you get x squared minus 36. This is a special type of product, and it yields a special type of factoring. It's called the difference of squares, meaning you've got two perfect squares. In this case, x squared and 36 are perfect squares. When you've got that, it will factor in a special way. So when you've got a squared minus b squared, you just look at their square roots, and you take a plus b. So for this first example, for our warm-up, square root of x squared would just be x, so x and x. Square root of 36 would be 6 and 6. You just make sure one is positive and the other one is negative, and there's your factoring. So we're going to start to look at factoring, and this is kind of a special example of that. I wanted to show you that. Now, here's the deal with a squared plus b squared. Typically, you will not be able to factor with addition here, but it actually turns out that you can. You just have to use complex numbers. And so a plus bi, a minus bi is the difference there. All right, so let's take a look at how we can use this to maybe help out with factoring. All right, so this first one, number 1, you've got difference of squares. Square root of x squared is x. Square root of 16 is 4. So your factors would be x plus 4 multiplied by x minus 4. Set that equal to 0. And now, look, I've got a product between our two parentheses. So I can set each equal to 0 and solve. So x equals negative 4. And then when you set x minus 4 equals 0, x equals positive 4 as well. All right. For this next one, sometimes your perfect squares will be a little bit more advanced. Rather than just having x squared, you might have 4x squared. Notice that it's still a perfect square. Square root of 4 is 2, square root of x squared is x. Keep those together, and then square root of 81 is 9. And so I've got 2x plus 9. Remember, the other one has to be the opposite, so 2x minus 9. Set that equal to 0, and now I look to solve. So I set 2x plus 9 equal to 0, so 2x equals negative 9, and x equals negative 9 over 2. And I set my next one equal to 0 and solve. So 2x equals positive 9, and x equals 9 over 2. If you notice, your answers are opposites. Negative 4, positive 4, negative 9 halves, positive 9 halves. That will save you some time to where you don't necessarily have to always solve for both. You just solve for one and then make the other one the opposite. Okay. Now, sometimes, again, perfect squares are going to be more advanced. So square root of 9x squared is 3x. Square root of 100y squared is 10y. So sometimes you might have to deal with multiple variables, in which case you've got 3x plus 10y and 3x minus 10y equals 0. Now, keep in mind here, I still want you to solve. So I still want you to solve for x, in which case, for the first one, you'd set 3x plus 10y equal to 0. Subtract by 10y on each side, so 3x equals negative 10y. And then divide by 3, so x equals negative 10y over 3. Now, the nice part is, remember, they're just going to be opposites. So your other solution, I don't have to go through all that work again. I can just say positive 10y over 3, and then I'm done. Okay, tell you what, let's take a look at number 4. And again, I'm going through each of these because, guys, they're going to show you something different every single time. So notice on number 4, where you've got 12x squared minus 27 equals 0, that 12 is not a perfect square and neither is 27. So what you'll want to do first, and what you should always look to do, is factor out a greatest common factor first. And so looking at 12x squared and 27, largest number I can divide both of those by would be a 3. So let's do that first. Let's factor out a 3. And so I've got 12 divided by 3 is 4x squared. Negative 27 divided by 3 is 9. I'm going to set that equal to 0. Okay. At which point, now if you look at what's in parentheses, now I do have perfect squares, to where the square root of 4x squared is 2x. Square root of 9 is 3. And so my factors is going to be 3 parentheses, because don't forget about the 3 in front. I've got 2x plus 3 multiplied by 2x minus 3. Set that equal to 0. Now I can start to solve. So set 3 equals 0, which isn't going to happen. Take 2x plus 3, set that equal to 0. So 2x equals negative 3. X equals negative 3 over 2. And remember, your second solution is just going to be an opposite. So positive 3 over 2 there. Okay. If you want to try one on your own, I will let you try number 5 on your own. Number 5 is going to be very, very similar to number 4. So look for a GCF first, and then look to factor by difference of squares. So if you want to pause the video, here's your chance. And here we go. So GCF, actually between 200 and negative 98, the largest number you can divide by is actually a 2. You end up with 100x squared minus 49 equals 0. At which point, you've got 2 perfect squares. Square root of 100x squared is 10x. Square root of 49 is 7. So you've got 2 parentheses, 10x plus 7 multiplied by 10x minus 7. Set those equal to 0. So I have 10x plus 7 equals 0, where 10x is equal to negative 7. So x is equal to negative 7 over 10, which means x is also equal to positive 7 over 10. Notice I did not set 2 equal to 0, because at this point, hopefully you're recognizing that if it's just a number, setting it equal to 0 isn't going to do much for you, in which case, just kind of leave it alone. Okay. So number 6. Notice number 6 is different. Now if you didn't notice, take a close look at it. On number 6, you've got x squared plus 16 equals 0. So notice here that there's addition. The only thing that's going to change is that it needs to be plus bi, excuse me, and minus bi. In which case here, what I'm going to have is square root of x squared is x. Square root of 16, what I'm going to use here is 4i. So I'm going to have x plus 4i and x minus 4i equal to 0. So I'm going to take the first one, x plus 4i equals 0, and solve that. So x equals negative 4i. And then just like before, other solution is just going to be the opposite. So x equals positive 4i as well. All right. That is all I've got for you today, guys. So what we saw today, just in summary, we looked at zero product property, basically saying that if you got two numbers multiplied by 0, at least one of them has to be 0. So set them all equal to 0 and just figure out what the answers are. With the greatest common factor, look for the largest number you can divide by and then factor that out. So what's left equal to 0 and solve. Number 2, notice again we left that. That'll be kind of what we'll lead with on Monday. So if you can have that ready for Monday, that'll be our intro to Monday's notes. And then we looked at differences of squares, whether it be with real numbers or complex numbers, and looked at taking square root of each term, using those to set up your factors, and then using zero product property to solve. So this is kind of our first alternative to quadratic formula that we've seen. So quadratic formula is one way to solve quadratics. Now we've got this kind of special case of factoring that we can use, and then we'll continue to see some different ways to solve. On Monday, if you wanted to preview that, we're going to be looking at solving by square roots, as well as going back to completing the square. So if you have kind of forgotten about completing the square, there's going to be something that's going to be coming back. We'll be looking at that in a couple days on Monday. Just as some reminders today, guys. Remember, there are 2 homework assignments due today. You've got the homework for 5.3 due by midnight tonight. You also have that complex numbers close read. That close read is due in class today. So please be sure, if you did not get that done, maybe make that first priority. Get that into the sub, or it will be considered late. Over the weekend, there's going to be homework on big ideas for what we just did in 5.4. So be on the lookout for that. And with that being said, guys, have a fantastic weekend. I will see you on Monday.